The concept of pyramid evolution refers to the historical and architectural progression of pyramid designs, particularly in ancient Egypt. This evolution marks a significant transition from the early, more primitive step pyramids to the grand and iconic Great Pyramids of Giza. Essentially, pyramid evolution explores how architectural techniques, religious beliefs, and socio-political motivations influence the development of these monumental structures over time. The significance of pyramid evolution is profound. It not only reflects advancements in architectural engineering and construction techniques, but also highlights the changing cultural and religious landscape of ancient Egypt. The pyramids served as tombs for pharaohs, embodying their divine status and ensuring their journey into the afterlife. This evolution provides valuable insights into how these priorities shifted and expanded, contributing to our understanding of ancient Egyptian civilization. A prime example of pyramid evolution is the Step Pyramid of Djoser, built during the 3rd dynasty around 2670 BCE. It marks a departure from traditional mastaba tombs, introducing the concept of stacking stone mastabas in a series of terraced steps designed by the architect Imhotep. Another renowned example is the Great Pyramid of Khufu at Giza, constructed during the 4th dynasty around 2560 BCE. The precision and scale of Khufu's pyramid represent a pinnacle of ancient engineering, showcasing significant advancements from the earlier step pyramid. Opinions on pyramid evolution often emphasize the remarkable ingenuity and resourcefulness of ancient architects and builders. Some scholars argue that this progression reflects an inherent human drive for innovation and mastery over nature. However, there are challenges in fully understanding this evolution due to the lack of comprehensive records and the physical deterioration of many structures over millennia. Alternative viewpoints include hypotheses suggesting that extraterrestrial influences played a role in their construction, though these ideas are largely dismissed by mainstream archaeology. Additionally, debates continue regarding the labor forces responsible for building the pyramids, with some arguing these were built by enslaved people. While recent evidence suggests a workforce of skilled laborers, pyramid evolution connects to broader aspects of ancient Egyptian society, including socio-economic structures, religious ideologies, and technological advancements. As the pyramids evolved, they influenced architectural styles and religious practices across other cultures, contributing to the spread of monumental architecture globally. Understanding this evolution enriches our appreciation of human history, showcasing how ancient civilizations adapted and innovated in response to their beliefs and environments. The Step Pyramid of Djoser, located at Saqqara, marks a significant leap in architectural innovation as the first monumental stone structure in ancient Egypt. Designed by the architect Imhotep for Pharaoh Djoser, it was constructed during the 27th century BCE. Unlike earlier tombs known as mastabas, which were simple, flat-roofed structures, the Step Pyramid was a revolutionary design. It consisted of 6 mastabas stacked on top of one another, forming a stepped structure that soared to a height of about 62 meters. This groundbreaking use of stone as the primary building material laid the foundation for future architectural advancements in ancient Egypt. The Step Pyramid's significance is immense in the context of pyramid evolution, serving as a prototype that paved the way for the construction of the more sophisticated and grandiose pyramids at Giza. It symbolized a shift from traditional construction techniques towards grander projects requiring advanced engineering skills. This innovation underscored Egypt's evolving socio-political landscape, showcasing the centralized power of the pharaoh and the capabilities of a cohesive workforce. One specific example illustrating the importance of the Step Pyramid is its influence on subsequent pyramid designs. The techniques and aesthetic principles pioneered at Saqqara were refined and expanded upon, leading directly to the development of the Great Pyramids at Giza. Another example is Imhotep's legacy. His architectural genius not only immortalized him in Egyptian history, but also influenced later civilizations, highlighting the continuous human pursuit of monumental construction. Opinions supporting the Step Pyramid as a pivotal moment in architectural history often highlight its role in demonstrating the possibilities of stone construction. It also reflects the creative ingenuity of the ancients, who managed to transform a previously simple design into an enduring symbol of divine connection and royal power. However, the construction of such structures was not without challenges or controversies. Some argue about the environmental and societal costs of such endeavors, including the potential use of forced labor. Additionally, there are debates regarding the extent of Imhotep's role and whether credit has been disproportionately attributed to him due to the lack of comprehensive records from that era. The Step Pyramid's influence extends beyond its immediate architectural successors. It represents a critical juncture in human innovation, serving as a testament to the ingenuity that drives cultural and technological progress. Its pioneering design set a precedent, directly impacting the construction techniques and cultural practices of subsequent generations and ultimately shaping the landscape of ancient Egypt. The development of architectural techniques and materials is a pivotal aspect of pyramid evolution, marking the transition from the early step pyramids to the grandeur of the Great Pyramids of Giza. This progression encapsulates the innovative spirit and engineering prowess of ancient Egyptian civilization. As architects and builders honed their skills, they enhanced construction methodologies and utilized new materials, ultimately achieving structures that have stood the test of time. The significance of this development is monumental. It not only demonstrates the Egyptians' ability to solve complex engineering challenges, but also reflects their understanding of aesthetic and symbolic considerations essential to their religious and cultural practices. The evolution of building techniques facilitated larger, more durable and more sophisticated pyramids, which in turn reinforced the pharaoh's divine connection and ensured their eternal rest and commemoration. A notable example of these advancements is the transition from the early step pyramid of Djoser, designed by the architect Imhotep, to the smooth-sided pyramids of Sneferu, particularly the Bent Pyramid and the Red Pyramid. Imhotep's use of stone instead of mud brick for the first time in large-scale construction marked a turning point, as stone provided greater durability. Sneferu further refined these techniques, pushing the boundaries of architectural design, experimenting with angles and shapes to achieve the smooth-sided form. Another key example is the construction of the Great Pyramid of Khufu, which incorporated precise alignment with cardinal points and innovative transportation methods for the colossal limestone blocks, highlighting the Egyptians' advanced understanding of mathematics and logistics. Supporters of the significance of these advancements often point to the extraordinary coordination and resource management required, which indicate a sophisticated level of social organization and a shared cultural vision. This ingenuity continues to captivate modern architects and engineers who study these ancient marvels to glean insights from their construction techniques. However, this evolution was not without its challenges and controversies. There are ongoing debates about the specific methods used to transport and position the massive stones, with theories ranging from simple sledges on lubricated tracks to more complex systems involving ramps or counterweights. Some alternative viewpoints suggest extraterrestrial intervention or lost technologies, though these remain speculative and unsupported by historical evidence. The development of architectural techniques and materials profoundly influenced other aspects of pyramid evolution, such as the socio-political structure, technological innovation, and cultural expressions of ancient Egypt. As new methods and materials emerged, they allowed for more ambitious projects, reinforcing the pharaoh's power and inspiring subsequent generations to build even more impressive monuments. The Bent Pyramid stands as a fascinating transitional architecture in ancient Egyptian pyramid construction. Located in Dahshur and built under the reign of Pharaoh Sneferu around 2600 BCE, this structure marks a pivotal shift from the earlier step pyramid design to the smooth-sided pyramids we associate with ancient Egypt today. The Bent Pyramid is named for its unique shape. It begins with a steep angle of 54 degrees, but about halfway up, the angle shifts to 43 degrees, creating a bent appearance. This change in angle is often attributed to concerns about stability and structural integrity, highlighting the experimental nature of pyramid construction at the time. The significance of the Bent Pyramid lies in its role as a bridge between the earlier step pyramids, like Djoser's Step Pyramid, and the later true pyramids, such as the Great Pyramid of Giza. This transition underscores a period of architectural innovation and experimentation, reflecting the Egyptians' evolving understanding of engineering and design. The The bent pyramid represents a crucial learning curve that ultimately paved the way for the construction of pyramids with perfect geometric lines, which became symbols of Egypt's architectural achievements. A prime example illustrating this point is the Red Pyramid, also built by Sneferu. It followed the bent pyramid and successfully achieved the true pyramid shape with its consistent angle of 43 degrees from base to apex, showing lessons learned from the bent pyramid. Another example is the Great Pyramid of Giza, built by Sneferu's son, Khufu, which perfected the true pyramid form, leading to its status as an architectural wonder. Support for the idea of the bent pyramid's significance often comes from those who view it as indicative of human ingenuity and persistence in overcoming architectural challenges. However, there are alternative viewpoints, such as the argument that the change in the bent pyramid's angle was not entirely intentional, but rather a pragmatic solution to a structural failure discovered mid-construction. This transitional phase connects to the broader topic of pyramid evolution by illustrating a critical period of trial and error that ultimately allowed for the construction of the pyramids that have captured human imagination for millennia. Understanding this progression from stepped to smooth-sided pyramids elucidates the blend of practicality and vision that characterized ancient Egyptian architecture and underscores the innovation required to achieve such monumental goals. This evolutionary process in pyramid design showcases the Egyptians' ability to learn from past mistakes, adapt their methods, and push the boundaries of architectural possibilities.